Hello, my name is Jun, and I am a junior in mechanical design engineering. This is a pleasure to meet you. Today, I will be explaining Ansys, one of the FEA software tools. Ansys is used for structural analysis, allowing us to configure it according to the desired materials and condition to derive the necessary value. Here are the context of the presentation. I will start the introduction, explanation, application, and conclude with a Q&A section to Ansys. First, the purpose of conducting structural analysis is to ensure safety, efficiency, cost reduction, and design optimization. And application of FEA include linear or non-linear static analysis, dynamic analysis, contact and crash analysis, fatigue analysis, float flow analysis, vibration and noise analysis. First, to get started with Ansys, downloading and install the software using the student or academic version. Once the installation is complete, launch Ansys 2024 R1 and run Workbench 2021. Uh, this is the site. The Workbench GUI is broadly divided into two main areas, with the toolbox containing analysis systems, component systems, custom systems, design explanation, and ACT. Among these, we will primarily focus on the analysis system. The analysis system consists of predefined analysis systems that can be inserted into the analysis system's schematic. We will cover the other categories later when we have more time. This is the content of Ansys Workbench. While there are various menus available, the most commonly used area include dynamics, statics, thermodynamics, and fluid mechanics. Today, we will focus on static, exploring its functions and application to objects. Statics, as the name suggests, deal with objects that are stationary and not subjected to external force. In statics, we have data, geometric, model, setup, solution, and research. I will explain each of these in detail. Data, define and edit material models used in analysis. Geometry, create, import, and edit the geometric model used in analysis. Model, assigns materials, defines coordinate system, and generates the mesh for the model. Setup, applies laws and boundary condition, establishing the basis for analysis. Solution, performs the model analysis and shares the analysis data with subsequent systems. Last is the research result, provides access to and indicates the state of the analysis result. We use engineering data to modify material properties. Ansys provides a set of material properties by default. Generally, we use general materials, and the detail of these materials are displayed as shown in the figure. By reviewing the material properties, you can see the details information. These details can be adjusted by setting the desired density, your strength, and the stiffness, allowing you to tailor the material properties to fit your design or the specific requirements of the object you are working with. Now let's move on to the application stage. In statics, click Import Geometry under the Geometric section to load the STL file for structure analysis. Then double-click on Model to execute it. If the shape shown in the previous image appears, the execution is complete. Now let's take a look at the setting shown in the right-hand image. We will start with materials and we can cover the previous contact later when we have more time. The left side is materials where the material properties you have set are displayed. The right side is coordinate systems which allows you to redefine the refer point of the object. This is useful when you want to apply force at a specific location on the object. Now let's discuss mesh. Mesh is essential in structure analysis. And the more mesh elements there are, the more precise the analysis will be. However, too many mesh elements can increase the analysis time and the data volume. So it's important to adjust the mesh size properly. There are two main methods for adjusting the mesh size. The first mesh size is the first method is throw diverge, where you adjust the particle size. Second method is throw a sizing, where you adjust the resolution from 1 to 7. Static structure allows you to apply various types of load to an object, such as force, pressure, heat, and rotation. Simply applying force to the object will not have any effect, so boundary condition needs to be applied, and this should be set according to the specific situation. In this case, I have applied a force load and a fixed support boundary condition. The force is applied in the x, y, and z direction with a magnitude of 5,000 Newton in the downward direction. Finally, solution. There are several types of analysis, but the most commonly used ones are total deformation equivalent is elastic strain and equivalent stress. The results are shown in the order of total deformation equivalent as elastic strain and equivalent stress. Each of these analyses provides insight into the degree of bending and the distribution of force based on the location. This is first, and this is second. This is third. This concludes my presentation. Thank you. This concludes my presentation. Thank you for listening. If anyone has any question, please feel free to ask.